Hello students, welcome back to the virtual class. So in today's class we are discussing about determinants of a square matrix. So determinant means it is of a matrix. So here matrix is a number that is associated with the square matrix and denoted by determinant A. See, this two parallel lines will be termed as determinants. You can write determinant like this also symbolically, or else determinant A. Okay, so this is we call it as determinant. See, determinant is always enclosed by straight line and not with bracket. That is very important. It is always enclosed by straight line, not with a bracket. See, the numbers enclosed by straight line do not constitute a matrix. Rather, they are the coefficient or the number assigned to a square matrix. So here we have two different methods of solving determinants of a square matrices. Okay, so here in this video I am explaining both the methods. So the first method is minor expansion method. So minor expansion method I am explaining with the order 2 into 2 as well as 3 into 3 matrices. So first one I am taking into consideration as 2 into 2 matrices. The proportional sign of determinants are. So here for the order 2 into 2 there is a proportional sign of determinant, that is plus, minus, minus, plus. That means the first element is having positive sign, second element is having negative sign. Again in the second row the first element is having negative, second element is having positive sign. This is how it will come. So when it comes to order 2 into 2, the determinant will be calculated as, so if we are having 4 element, we have to cross this. Okay, so AD minus AC. AD minus, wait a minute. So this is AD minus BC actually. Okay, I have did a mistake here. So it is always be like we are cross multiplying this. So AD as well as BC. Okay, this is how we have to calculate determinants for the order 2 into 2. Okay, so here I am taking the example sum to explain how to calculate determinants under minor expansion method when the order is 2 into 2. Okay, so look at the question. Here they have given matrix A as 2, 4, 6, 8. We have to find determinant A. So very simple, determinant A will be represented in parallel lines. Write this 2, 4, 6, 8 all the elements. Then what we are doing for 2 into 2 order, same cross multiplication, that is 2 into 8 minus 6 into 4. So 2 into 8 is 16 minus 6 into 4 is 24. So determinant A is equal to minus 8 you will get. So very simple. So keep this rule in mind. Cross multiply, we have to write the elements as A, B, C, D. So cross it, AD minus BC you will get. Okay, so in between we will have minus sign here when the order is 2 into 2 matrices. We'll take up the next method, that is under minor expansion only. I am taking the next sum, that is for the order 3 into 3 matrices. The proportional sign of determinant will be like this for 3 into 3 matrices, that is plus, minus, plus, minus, plus, minus, plus, minus, plus. When the order is of 3 into 3, how we will going to write the determinants? See how under 2 into 2 we are writing it as AD minus BC. Very simple, we are cross multiplying. When the order is 3 into 3, what we have to do? Okay, see very simple here. A determinant A is equal to, if you are considering the first element, okay, that is A1. So what you have to do is eliminate the first row and the first column. So whatever the remaining you will get, that has to be written here. Okay, so getting it, that particular, the elements, particular row and column should be eliminated. So whatever remaining elements you have, that has to be written here. So here the sign of determinants are plus, minus, plus. As we are considering the first row, we are just considering the first row when the order is 3 into 3 to find the determinant. Okay, so here order is 3 into 3, right? For A1, the sign of the determinant should be positive. So that's why we are not mentioning plus sign here. It is understood. Okay, so that's why we are not writing plus. When it comes to second element, see, we are specifying with the negative sign. So second element in the first row is B1. So if you are considering B1, so that particular row and column should be eliminated. So whatever remaining element you have, that is A2, C2, A3, C3, has to be written there. Okay, again we have to look at the third element, that is C1. So C1, the third sign should be a positional sign. That is for the third element, the positional sign is plus. So write the plus C1. So if you are considering C1, eliminate the row and column which it is belongs to. So remaining you will get A2, B2, A3 and B3. Okay, so this is how you have to write the elements first, then simplify it. Okay, so I am taking the example sum here. Okay, A is equal to, they have given the matrix with the order 3 into 3. We have to find determinant A. So determinant A is equal to, write all the elements as it is 179. Okay, so if you are considering the first number, that is 3, so you have to eliminate the row and column which it is belongs to. Remaining numbers you have to write. So you'll get 0, 2, 7, 9. Then minus the second element is 4. Okay, write it. If you are eliminating this 2, you will get 8, 1, 2, 9. And plus 6, eliminate the row and column, you will get 8, 0, 1, 7. So after this, very simple, write 3. So how we used to do for when the order is 2 into 2, we will cross multiply it. Same way here we have to do. 0 into 9 is 0, minus 7 into 2 is 14, minus 4. Now 8 into 9 we have to write. Okay, so 8 into 9 you will get 72, minus 2. So in between we have we should have a negative sign, plus 6. Positional sign will be based on the this one. Okay, so we have next 8 into 7, that is 56. Then 1 into 0 is 0. Okay, so here 3 into minus 14, minus 4. 72 minus 2 is 70, you will get plus 6, 56. So multiply this. 3 into minus 14, you will get minus 42. So 70 into minus 4, you will get minus 280. Then plus 6 into 56 is 336. Add this to those who are having negative sign. Then subtract 336. So you will get determinant A is equal to 14. So this is how you have to calculate. See, this is a basic thing. If you can able to remember this, you can able to solve the sum. Okay, so very easy and simple. Okay, and the sign is very important. So this thing you have to keep in mind. And in between always will get negative signs. Okay, only here to in front of the elements the sign will keep on changing based on positional sign. Okay, this is when the order is 3 into 3. Okay, this is under minor expansion method. We have a second method, that is series diagram method. So here it is also having a rule like how we used to do under minor expansion method, but not exactly similar, but it is different. See, I am already written the method of solving the determinant or finding the determinant under series diagram method. So here, if we are considering a matrix A of the order 3 into 3, so what we have to do is, first we have to write all the three numbers of the first row. Again you have to write the first and second numbers. That is what I have written here: A1, B1, C1, again A1, B1. Okay, then A2, B2, C2, A2, B2, A3, B3, C3, A3, again B3. So here we have a formula for it also. So S1 is equal to, you have to consider the elements in the straight line. Okay, so that is A1, B2, C3, then plus B1, C2, A3. Okay, then C1, A2, B3. This is S1, we will call it as. Same way we have S2. S2 will be in the from the backwards. Okay, we are writing it. So it will be all in the dotted straight line. You have to consider C3, A2, B1, B3, C2, A1, A3, B2, C1. So determinant A is S1 minus S2. Okay, so I am solving one example sum so that you will understand it better. Okay, so here, so what we have to do is, we have to write according to this way, right? So you will get 1, first I'll write it in the determinant format: 1, 2, 3, 4, 5, 6, 7, 8, 9. So as for this is 1, 2, 3, again 1, 2, then 4, 5, 6, again 4, 5, 7, 8, 9, again 7, 8. So the straight line has to be taken first, then afterwards the dotted line, that is okay. So that is equal to, so S1 is equal to, so how we will write it as, see 5, 1, 9, right? So that is 5 into, sorry, 1 into 5 into 9. We are using plus sign here, okay, in between. So there we are using negative sign, that you have to keep in mind. 2, 6, 7 plus 3, 4, 8. This is S1 minus, I am doing it directly, S1 minus S2. Okay, so minus, or else you can write S2 separately. So S2 is 9 into 4 into 2 plus 8 into 6 into 1 plus 7 into 5 into 3. So you A, determinant A is equal to S1 minus S2. So I am taking it directly. See, 5 into 1 is 5, 5 into 9 is, you will get 45. So S1 is, okay, I'll write it here. S1 minus S2, right? So 45 plus 2 into 6 is 12. 12 into 7 is 84. Again 12 into 8 is 96 minus, so 9 into 4 into 2, so you will get 72 plus 8 into 6 into 1 is 48 plus 105, 7 into 5, 35 into 3. Okay, so total you will get it as 225 minus 225, that is equal to 0. So determinant A is 0. So very simple. You have to keep this thing in mind when it comes to Serro's diagram method. So when it comes to minor expansion method, that basic things has to be, you have to remember. If you can able to remember that concept, you can solve any sum, okay, without much difficulty. Okay, hope you can able to solve the sums based on the examples what we have discussed today. Okay, if you are having any doubts or confusion, kindly watch the video again so that it won't be confusing to you. So, and I'll going to give the assignment sums based on this 3 sums what we have worked. Thank you.